I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today in this video we will detailedly discuss about a video lecture on operational amplifier. Simply we can call it as op-amp. So this operational amplifier is made up of the IC, that is a integrated circuit with a combination of many transistors. So an operational amplifier is a DC coupled electronic amplifier with a differential input, a signal ended output voltage, and an extremely high gain. So low, you can use low by using the lower input. We can build the amplify the maximum output. So it names comes from its original use of performing mathematical operations in analog computers. So this is the operational amplifier. So this is a symbol of operational amplifier. There are two terminals, non-inverting terminal and inverting terminal. Then two voltage, input power supply, negative voltage and positive voltages is there supplied. Then output we can get. So this is the triangle with 5 terminals. That is the operational amplifier. So by using this amplifier we can utilize many applications. So the IC number, that is IC 741, is the operational amplifier particular this case. So doing math with electricity. So before digital code, the operational amplifier performed mathematical operations like arithmetic operations like addition, subtraction, and integration using voltage. So this operational in the name refers the mathematical operations. So simply can say the explanation of the operational amplifier using the example with the problems. So let's see the 3 beakers with the water. So different level of waters. Then we are heating up the waters. So this is the problem. So we want to find out the average temperature. For first beaker, its temperature, that is 25 degrees Celsius, and second beaker, that is 50 degrees Celsius, then third beaker 75 degrees Celsius. So we want to find out the average temperature of these 3 beaker and water temperature of the water. So let's see the analog solution for that. So here we are using the 3 different resistance, and by using the op-amp, then reference feedback resistance also we are using. So 2.5, 5 volt and 7.5 all summing up, and will go to the operational amplifier as input. Then by using the reference feedback resistance, then we'll get the output as 50 degrees Celsius as the average output. So by using this simple circuit, you can find out the average temperature of the particular problem. So this is the way the operational amplifier is working. The anatomy of the symbol already we have discussed. There are 2 terminals, that is inverting input and non-inverting input. Then positive power supply, negative power supply, 4 terminals, and then 1 output, amplified output voltage. So the universal language for this operational amplifier is 5 terminal triangle. So 5 terminal with a triangle. This is the anatomy of the operational amplifier. So inside the black box, inside the IC, so although it looks like one component, an op-amp is an integrated circuit. We know that containing complex cascaded of transistor stage. Different stages of transistors are available inside the operational amplifier. One by one we'll discuss input stage, intermediate stage, level shifting stage, and output stage. So this the step-by-step process is happening inside the operational amplifier. The core principle of the differential amplifier or amplification is op-amp amplifies the difference between the 2 inputs, not the absolute voltage. So here we can output voltage, that is equal to A into V1 minus V2. So V1 minus V2 is the difference between the 2 voltages. So suppose to see the diagram, input A and B different input values, then we'll get a output like that, V out. So if the conditions is if V1 is greater than V2, the output is positive. If V2 is greater than V1, then output is negative. So this is the principle of operational amplifier for particularly difference amplification purpose. The open loop gain, so without feedback we are using the gain AOL is massive at 1 lakh plus value. So even microvolt difference causes the output of saturated instantly increases. So see the diagram for differential output voltage. So saturation point is is negative, limited by the power supply. Then output gain in saturation region is maximum in the positive directions. So the linear region slope infinite gain will get for the small amount of voltage also. So negative feedback, how it is working in the negative feedback with my open loop and closed loop, how it is working. So to make the operational amplifier stable and linear, we feed the output back to the inverting input. So we are supplying the inverting input. So the first diagram, that is the open loop. So V1, V2 is the input, V out is the output. So the wild, unstable and comparator mode. So the open loop means it's unstable one. So to stable the output voltage, we need the closed loop, that is stamped, that is the linear amplifier mode. So we are introducing the reference, feedback resistance also with the V2 and V out. So we will get a stable output. The golden rule for the operational amplifier, that is for an ideal op amp with a negative feedback, these two rules are allowed to you analyze the almost any circuits. So first rule, that is current rule. So no current flows into the input terminals because input impedance is infinite. So there is no current flows into the input terminals. So impedance is very high. Then second rule, the voltage rule. So that is the operational amplifier adjusts the output to the voltage difference is 0. So voltage difference is 0. So V virtual short. So V plus difference 0. Then V plus is equal to V minus. So this is the second rule. Then ideal versus practical. So ideal operational amplifier versus practical operational amplifier. The practical operational amplifier, that is ICLM IC 741 we are using here. So this is the parameters comparison. Then input impedance for ideal operational amplifier is infinite. For practical, for example, okay, so the input impedance is infinite, 2 mega ohms. Output impedance is 0 for ideal, then 75 for practical. Then open loop gain infinite and 20,000, 2 lakhs. So bandwidth infinite and in 1 megahertz. Then offset voltage is 0. Then the offset voltage is 2 to 6 millivolts. These are some applications. We can utilize the op amp as a comparator. This is the open loop circuit. Then second application, the amplifier, you can use this inverting amplifier, non-inverting. There are two types is there, inverting amplifier and non-inverting amplifier. So we will discuss detailedly about inverting and non-inverting later in forthcoming videos. Then third application, this is the analog summing. So summing in difference amplifier also we are using by using the operational amplifier. Then advanced applications like active filters, oscillators, ABD, analog to digital converters, and then voltage followers. These are all the some major advanced applications of operational amplifier. So thank you for watching this video. Thank you.